So far, we have seen the different benefits from different stakeholders. The cost benefit sharing is defined by a systematic and system oriented incentive system that motivates a company in a network to participate in a joint project that do not benefit them directly. A joint project is a cooperative effort to improve the process or resource allocation in a network. It involves at least two parties in a network. The definition is the cost benefit sharing is a method to accomplish the process changing project in network. It is based on a stakeholder oriented total cost analysis of all packages of a measures in a project. Based on the achieved transparency of the positive and negative benefit, a win-win situation is provided through reallocation strategies for all stakeholders. Therefore, an incentive to network-wide optimization is given. In this definition, a cost and benefit transparency between the stakeholders is suggested to achieve a win-win situation. Unfortunately, this level of transparency is quite often not wanted by companies. And we will be seeing the cost benefit sharing process loop can be structured in several subtasks. The first task is detailed process analysis in the network through auditing. The next one is inquiry of the weak point through benchmarking. Third one, development of the corresponding action to solve or lessen the effect of the weak point based on the overall strategies and goals. The fourth one is the cost benefit sharing, that is includes calculation of cost, evaluation of benefit including the monetary benefits, quality benefits and the total benefit, and calculate the share of the benefit for the individual stakeholders. The last one is the distribution of the cost. How we will be distributing the cost to individual stakeholders. The fifth step is the implementation of action proposed in step 3, that is the development of corresponding action to solve, lessen to affect the weak point based on the overall strategies. The sixth one is controlling. The seventh one is feedback loop to adjust the system to external dynamics. What actually we are telling is we we have to frame an audit and identify the weak point because the individual stakeholder will have the individual weak points, but there is a maximum benefit will be given to some stakeholder. In a certain situation the maximum benefit will be obtained by the society. In certain cases the maximum benefit will be obtained by the company. The whoever getting the maximum benefit, they have to share the cost level to the other stakeholders. So that is what the this loop, and we have to regularly get the feedback from the loop and adjust to the external system dynamics. Next, we are going to see about a technical framework for integrating billing capabilities into the EPC global framework. A possible solution to overcome the problem of cost benefit sharing in IoT may be based on integration of a billing solution into a EPC global framework. The EPC global network is a standard of electronic coding technologies. So electronic coding technologies will flow from the suppliers, will be having the raw materials, and next is a warehouse. From the warehouse, based on the continuous lines or EPC barcode, and next to a form is the real world goods. It will travel through the suppliers, warehouse, manufacturers, distribution center, and retail store. It is similar to the ration shop, what we are used to purchase our home goods. So, and also many solution has been applied here. So, how we are going to make this EPC system to our IoT? So, for that we take the prototype. The test scenario has been set up at Log Dynamics Lab in Bremen. A two open source product has been chosen for the implementation. The well-known FastTrack and the JBilling. So two are the open source. So the implementation is very simple. And also there is no proprietary is involved being involved in that. Firstly, it does not require any upfront investment software. Secondly, it is open source, therefore allows a modification to the software. And thirdly, it aligns well with the technologies used in Fastrak and therefore may allow the tighter integration. The both product use a Tomcat, a web server, but there are two different relational database in use. The Hypersonic for JBuilding and MySQL for Fastrak. So the hypersonic could be eliminated in the further integration effort. To combine these two systems, there are two initial requirements being needed. There should be an integrated login procedure and selected EPCIS event should be translated to the JBuilding purchase orders. Any change to the customer corresponding to the purchase order in JBuilding, these are included in the subscription and single purchase taxes and interest. For example, if I am going to purchase by using the Fastrak identity, it will be replicated in the JBuilding software. The billing may be whatever based on the purchase. If it is on monthly installment, it will be has to be replicated as a monthly installment. So there is a billing process being between the Fastrak and JBuilding, and how the communication is being established is shown in this particular figure. So kindly rotate your screens so that for the effective viewing. So the billing process is divided into five different groups: the customer EPC, and the EPC global framework, and the billing interface, and the JBuilding, and the customer billing. The starting from the customer EPC global, the event will be triggered. It will be received by the EPC global network, such as capturing the event, and authorization will be made based on the already synchronized login APIs. If the authentication is successful, it will be transferred the control to the new agreement request. So then the query was made whether the particular product is being available by a simple SOP call. Already we have seen the SOP call. The billing API will update the orders. Based on the order, the electronic bill will be generated. So these are the five-step process is being made in the billing process between Fastrak and JBuilding. So next is the interface and how the electronic order copy will be generated based on the EPC query. So this is what are the transaction we have so far made. It can be seen over here. So this is how our order details will be displayed over here. So there is a communication will be not a alphabetical component. It is a kind of integer values. Already the system is integrated, so we can say that the integer value 0 means the user was successfully authenticated and his current status allow him to entrance into the system. So only then you can able to make a query. Without entering into the authenticated system, you cannot make a query. So the one indicates invalid credentials. The username and passwords are incorrect, which will be given to the individual employees who are working in the particular infrastructure. It may be in the warehouse department, or it may be in the distribution segment. So number two, the locked account. The user or the password are incorrect, and this is the allowed login attempts. From now on, the account is locked. The number three record the password is expired. The credentials are valid, but the password is expired. The user need to change it before logging in. These are the written value for the authorization process from the JBuilding. The user scenario for the beverage industry, a simplified supply chain is being represented in the right side figure. So it is a kind of a EPCIS, information system event. The physical actions such as start from the pool operator, bottler production, and bottle warehouse, and the wholesaler and retailer. The the pool operator will collect from the scrap and the procedure by and outgoing RTA, that is the right way information. In the bottler production, decommissioning and incoming empties are being conducted. And the bottler warehouse, the outgoing empties, incoming empties are being recorded. The wholesalers, the outgoing empties, incoming empties are recorded. The retailer, outgoing empties and commissioning is being made. So The object event add and object event observe is made in the pool operators. The aggregation event add, aggregation event observe, and aggregation event delete are the components which can be made in this simplified supply chain scenario for the beverage industry. So the cost type which is being involved for adapting the already existing the billing component to the IoT environment, or what are the different cost type is being available, we'll be discussing it. The beverage cost price, example, the bottler outgoing goods, the per pallet. For example, we know it will be supplying in terms of pallet. The deposit, the pallet dolly tray bottle. Example, the event calculations or bottle end of productions, aggregation add event delay. The fixed price per event. Deposit refund, the pallet dolly tray bottle, the bottler end of production, aggregation event delay. The fixed price per event. The price structure is fixed price. Nothing is going to vary. The usage based free pallet. The retailer outgoing goods, usage based per day. Initial fee, account to opening, fixed price only once. The monthly IT infrastructure, initial contract period is around 12 months. The percentage of purchasing cost per month. The monthly information is the initial contract period, and flat fee per month. The premium query is query that are not covered through monthly contract. Usage based events. So these are the various cost types that is being that can be available, will be available in the beverage market. So discussion. So far we have seen about the cost and benefit of IoT has been presented, and the concept of cost benefit sharing has been evaluated. The technical solution has been provided for integrating billing into the future IoT, such as we have seen the framework for a J billing with the fast track, how we are going to integrate these components, and how the prototype has been developed, we have seen so far. The concept has been validated by developing a prototype that combines the open source billing solution with the open source implementation of EPC Global EPCIS standard. The beverage scenario has been used here to illustrate the technical prototype. The overall goal of the prototype integration of the billing system with EPCIS was to provide a means for charging the information access, thus enabling the free trade of information within the IoT based on the market forces. So that's all. We have seen the integrated billing in IoT systems. Thank you.